This is some recommendations that I have for securing data at rest. There are supposedly good means of securing data on the wire between organizations, between machines, but from my experiences, more effort needs to be put into securing the data that is kept in systems once it's inside of an organization. And obviously that's going to involve a lot of encryption. There's a few, three different encryptions: asymmetric, symmetric, password-based encryption, where you use somebody's password as the encryption key, and one-way encryption, basically where you digest a piece of information down into a known quantity just so you can verify the same is put in every time. And something like that would be checking a username, maybe. Anyway, my first and foremost recommendation is segment identifiable information away from, I guess, what you'd call day-to-day information or ledger data. So identifiable information versus ledger data: names, social security number, addresses, phone number, Gmail, etc. Anything that identifies an individual, points an individual, should be kept in a separate database, separate system. And the reason for this is when you have systems, which are databases, files, etc., you're going to give people access. If you give people, the same people, access to that as that, they could put two to two together and cause some nefarious purpose. If they only have access to the IDs, probably not going to know what they might do with it. If they only have access to ledger data, it's pretty much garbage anyway without IDs. So they're not going to be able to effect any nefarious purposes. So, and for example, you have a DBA for this one, DBA-A, and for this one you have DBA-B. And those two would have separate security vetting requirements placed upon them. And unfortunately, I don't have my napkin. So, step A. Step B is of course, use TLS. Everybody knows TLS. You're going to have a load balancer here. And you don't use layer 7 load balancing. You can only use 2 and 3 because you need TLS to go all the way to the worker unit. And you can still use TLS here because inside of the organization, basically, you still want any eavesdroppers, including people who work at the organization or people who somehow have access to it, to not be able to spy on that data, not voyeurism on that data. So these are worker units, and they're going to have access to that data that I was talking about. And the best thing for them to do would be use ephemeral certificates for their TLS, so that this one could be different. This security secret key and this secret key can be very short term, easily kept secret, and different from these. So anybody with access to this will not be able to check out that stream, will not be able to check out this stream. And thus. And there's already a way to do short-term certificate requests, and that is the ACME protocol. And there's also another system where you can use a main certificate authority, and then you can use an intermediate authority. And what you might do is, an ACME is actually one of, some ACMEs are one of these. But what you really might do is, for if you want to make this extremely short term, is make this automatically get a cert from the intermediate that you host yourself, and then the main cert will just verify that. And so the question, of course, is how is this not corrupted? And I'll get to that in a second. But anyway, you'll use TLS inside of the business also, with ephemeral certs probably, and then you can have as many worker nodes as you want with as many certs as you want. So how are you going to secure this? That's down there. When you start an application, applications are usually run by something that, like Kubernetes, which spawns them, and then they have some database that they draw their security keys or login information from, called Vault. So they need to start from somewhere. So when you start an application and you start getting worker nodes spawned, what you will do is, the first thing you'll do is have some very secure controller put his password in. This would be password-based encryption, and he will draw out a key that's garbage, but it will be decrypted with his password to become another encryption key, which will then enable him to talk to the intermediate. And so you will literally need at least one person to verify who he is in order to start applications running. They will, like I said, they will have this key from his password, and that will also get him into so-called vault. And once that gets him into vault, then that can get him in there. And of course, you'll have perhaps multiple ones of these guys, and A, B, and C, and so they will each have different ones that they can pull out and decode. So you can run them either on different parts of the earth or different parts of the campus or wherever. So you can have multiple people. And if it's really important, there's one more step you can take. For example, starting IRS things or mil-spec. You can use password-based encryption in a special way, wherein these guys who logged in, same three guys, Same three guys, each have their own password that's going to be an actual encryption key or decryption key for three different otherwise garbage pieces of data. But once they decrypt that to get their own little number there, they have to be put together in order to make a complete encryption key to get into Vault. So now you need all three people to put their decrypted key together to get into Vault and to start the very important secret app. And then once that app is rolling, it can go to places that otherwise expect it to have a full key. So there's that. Now back to where I started, where you separate ID from ledger data. What you want to do is every piece of ledger data will have some control number which relates it to a specific ID of some sort, or maybe two or three, but anyway, control numbers which relate IDs to ledger data. If the control numbers are in a clear, eventually somebody could compromise this system, maybe it works on both of them somehow. And put two and two together. So you're going to need to use password-based encryption on control numbers. So at least in ID, you will not see anything in the clear. This will now be garbage, and you'll need those same three guys, perhaps, or another three guys to log in, to decrypt that, and then you'll have access to the data. But you still want least privilege to be in effect on even ledger data. It's not right for anybody who has access to all this ledger data to have access to all this ledger data. Maybe one or two very approved people should have it, or use another means of making sure passwords don't get lost, but it should be separated into groups. And obviously there's people who will work on it for at least people's concern. It should segregated into groups, and those should be assigned to certain people. So group of people A will get to work on group A data, and B on B data, etc. So how are you going to do that? You'll use a layer of dereference. As I said, you will firstly encrypt most of this data, right? Maybe you'll have the control number that matches it up, but all this data inside here will be encrypted, or at least anything material that can be used for nefarious purposes, if compromised, needs to be password, or needs to be encrypted. So you make it password-based encryption, and you have a password. Would you just give that password out? No, you don't do that. You have a procedure where you assign it to guy A, A1, A2, A3, and they will use their passwords to encrypt that for group A. So each one of them can log in, get this key based upon their password, and therewith encrypt only A. Then you'll have another group for B and another group for C. A will never be able to decrypt anything in B. B will never be able to decrypt anything in A. C will never be able to do either of those, but will be able to do C data. So with this procedure, you have effected access control lists, basically. The access control list for A1, 2, and 3 is effected by the encryption with A's key of the data kept in for the group A. So you got access control listing now. And that is sharding, basically. So now you're combining sharding with path-based encryption and encryption in general, and it's data at rest. So I've gotten through it. And of course, this is meant to effect good security, and most importantly, my concern is confidentiality. That's the C in this. The other is integrity. It can also impact integrity, because if you can't decrypt it, you're not going to be able to change it very well. And if you try to change it without decrypting it and writing it back, encrypting it back, you're just going to end up with garbage. So at least confidentiality and integrity are affected. And availability is another complexity, but with availability, you might use one-way passwords, one-way encryption on it. So now you've got good security on your data at rest. You've got the database sharded between ID and ledger data. You've separated ledger data into chunks, so you have ACLs sharded into chunks. You got ACLs. An example of that is maybe everybody in Tampa gets worked on by team Tampa. Everybody in Atlanta gets worked on by team Atlanta. Everybody in Hong Kong gets worked on by team Hong Kong, and they can't look over each other's data. And it's all encrypted. This is especially encrypted, of course. ID information is especially encrypted. And the person who manages that database will not manage this. And that'll be encrypted. And the communications between the worker nodes and that will be encrypted. And you'll use TLS on this side of it, but it's encrypted data going on this side, so it's not that important. Although you may still want to use some TLS there, and for DBAs who are assigned to this, they can still do searches, etc. on it. But they won't be subjected to the specific information. It's automatically, another keyword, redacted. You can't violate Hipaa. You can't violate payment card industry standards. You can't violate the Security Act because it's just garble to regular people like DPAs and software programmers. You actually have to be some type of promoted operator with password-based encryption key to get in there and actually look at and impact the data. Let's see. And since this is all so secure, there have been some breaches where obviously this information, like ID information, and the plastic card or payment card industry specifically has leaked some data, and everybody's credit card numbers are out in the dark web. They will now be encrypted, and even if malware magically gets into this system, it's not going to know what to do with this. There's no keys out floating around here. There's no search in here that's going to help them out. Malware can search in on this. They're just going to see garble going back and forth, basically, because it's all encrypted. There will be keys in here, and you're going to want to make sure your apps are secure and that the data, the memory that this is using is not somehow being inspected by a malware or operators on the machinery, etc. But that's pretty hard, so and should be easier to handle. And even if they get into the data in this, it's going to be quite a mess. So, and there's probably ways to, there are some ways to encrypt and obfuscate usage of it. So it also makes it very robust against malware. So you got redaction. You got redaction for regular folks. You got access control lists. You have very good security. And let's see if there's anything else. You got confidentiality, integrity, availability. Obviously, you're going to do backup schemes. So when you do a read and write, you'll set it to another system that keeps a good copy. It'd be good to have write-ahead logs that can be played back and get the data, etc. So I think that sums up my recommendations on the matter of securing data at rest inside of organizations that keep and use data.